In this video, I'm going to teach you how to find the derivative of a function. So let's start with finding the derivative of 4. So, or a constant. So how to find the derivative of a constant? So derivative of a constant is always 0. So if you say constant, the value is fixed, unlike some variable x or x squared or y. The values of those variables is not fixed. It can be any number. But here we have 4 and the value of that is fixed. It's constant, it will not change. As well as pi. Pi is a symbol, but it's not a variable. It has a value which will not change. It's always around 3.14 and so on. So the derivative of pi is also 0. As well as the e, the constant e, or the Euler's number. So it has a value of around 2.72. So, and this is one of the examples of a constant because the value will not change, and the derivative of e is equal to 0. So that's the idea. There is the derivative of any constant is always 0. Now let's find another expression or function. To find the derivative of 2x cubed. So we have an expression or function with only one variable, and how to find the derivative of this. So first is we're gonna copy it and we're gonna put some space in between them because we're gonna have product between 2 and something. So it will be 3. 2 times 3. Where did we get 3? We just copy it from the exponent of x. So if it's x to the 4th, then it's going to be 2 times 4. If it's x to the 8th, then it's going to be 2 times 8. And then we will subtract 1 to the exponent. So why 1? Why not minus 2? Why not minus 3? The 1 is fixed. There's always minus 1 when you're trying to get the derivative. So it's always minus 1. Whatever is the exponent, if the exponent is 5, it's still minus 1. If the exponent is 8, it's going to be 1. So still it's always 1 whatever is the exponent, and that is fixed. Now let's solve. So this will be equal to 2 times 3 is 6, and the exponent will be 3 minus 1 is 2. So the final answer is 6x squared. So another one. So let's say we're gonna find a derivative, or sometimes the instruction is differentiate. So it's the same as find the derivative of 5x. So this is if the expression has a variable with exponent 1, this is x to the power of 1. That will be very easy, and I'm going to show you the result when you take the derivative of this function. So it will be 5 and x to the power of 1. So it will be times 1 because the exponent is 1. And we're going to subtract the exponent by 1 because it's always minus 1 to the exponent when you take the derivative. And then we simplify. 5 times 1 is 5. And the exponent will be 1 minus 1 is 0. And x to the power of 0, or any number or variable to the power of 0, is always 1. So it will be 5 times 1, which is 5. And this is what I am saying. It's gonna be very easy if you are taking a derivative of a number times a variable with an exponent 1, because you just have to remove that variable and just leave the number. So 5, the derivative of 5x is 5. Now how about this? Find the derivative of 10x. So of course it's the same problem with the previous one, so I'm just showing this to emphasize. So the derivative of 10x will be 10. So because it's only x to the power of 1, so just remove x. Derivative of 8y is 8. The derivative of 2c is 2. Derivative of 3m is 3. So it doesn't matter what variable it is, what letter it is, as long as the exponent is just 1 and it's only one variable, Then you just have to remove the variable and just leave the letter and just leave the number. So that's the derivative of that function. Now let's have another example. So find the derivative of x cubed plus 5x squared plus 1. So there are three terms. So how are we going to find the derivative of this? So it is just simple. It's similar to the previous ones. It's just that there are three, so we're gonna derive each of these terms. So we'll start with the three with the x cubed. So of course we're gonna put the three the side of x. That's the rule, and you subtract one to the exponent. So that's 3x to the power of 3 minus 1. And then plus. So the same way we're gonna derive 5x squared. So we're gonna put the 2. So it will be 5 times 2, and then subtract the 2 by 1. And then plus the derivative 1. So since it's constant, so the derivative of any constant is 0. So let's simplify. It will be 3x squared plus 5 times 2 is 10, and 2 minus 1 is 1. Or we can remove the 1 to the exponent, which will be 3x squared plus 10x. Now how about this? Let's find the derivative of 2x cubed y to the fifth. So now it involves two variables. So it's composed of a product of two functions, the x and the y. So there are two groups in this expression, the 2x cubed and the y to the fifth. So how are we going to derive if it's a product of two functions? So this is how you do it. You copy the first group, the 2x cubed, and derive the other group, which is y to the fifth. So the derivative of y to the fifth, put the 5 and subtract 1 to the exponent. Plus, then now the vice versa, copy the y to the fifth and derive the 2x cubed. It's gonna be 2 times 3, then subtract exponent by 1. So this is what you call the product rule. So if 2x cubed is your u and y to the fifth is your v, then it's gonna be u dv plus v du, or u times the derivative of v plus v times the derivative of u. So let's simplify this. It's gonna be 2x cubed plus 5y to the fourth, subtracting the exponents, and as well as the 2 times 3 is 6, and the exponent 3 minus 1 is 2. Simplify further, we have 2 times 5 is 10, and put the 6 at the left side. So it's gonna be final answer 10x cubed y to the fourth plus 6x squared y to the fifth. Now another one, find the derivative of 4x cubed over y squared. So this is now the same idea as divide. If the previous one is multiply, this is division. So we have two functions, 4x cubed and the other one is y squared. So what's the rule if it's division? So this is how you do it. You copy the denominator y squared and multiplied by the derivative of 4x cubed. That's why it's 12x squared. So it's 3 times 4, 12, and the exponent 3 minus 1 is 2. Then you will subtract. So if the product rule is plus, then the quotient rule is minus. The same idea with dividing. When you divide expressions, you subtract the exponent. When you multiply expressions, you're going to add the exponent. So that's the same idea. So now you will copy the one on top, so it's the vice versa, and then you derive the denominator. So derivative of y squared is 2y. Then all over the square of the denominator, square of y squared. So that's how you do it if it's a ratio or a fraction. So that's what you call the quotient rule. So let's simplify this. So 12x squared y squared minus 2 times 4 is 8. So 8x cubed y all over. So y squared squared, we're gonna multiply the exponent. It's the power for power, y to the fourth. Now we can simplify this further. So um, let's remove some. Let's have some other space to continue. So let us put the last solution and then continue. So how can we continue this? On top in the numerator, we have a common variable y. Although we have a common variable x as well, but we need the y because y can be cancelled with the denominator. So let's take out the y, and so let's copy the y to the fourth, and then we cancel this. So again, we didn't take out the x, although it's common because anyway, the x cannot be cancelled because there's no x at the bottom. So it depends on the reason for you and why you will take out or why will you factor out. But still, it's the same. It's still correct even if you take out the x. So it's up to you. So I'll just cancel this because we can divide both by y. So this becomes 1 and y to the 4th divided by y is y cubed. So the final answer will be 12x squared y minus 8x cubed over y cubed. Now how about this? Find the derivative of e to the power of 4x. So this is, we have a constant e, an Euler's number, where it is approximately around 2.72. And that means it's a constant. But how do you find the derivative if it's in this form, involving a constant e? So let's derive. This is how you do it. Copy the e to the 4x, just copy it, and then multiply it with the derivative of the exponent. So the derivative of 4x is 4. And that's it. Then simplify. So this is equal to 4e to the 4x. Another example. Find the derivative of 3 to the power of 2x. So this is similar to the previous one, although it was a constant e, and this time it's a constant number, 3. So it is a bit similar to the previous one, but a bit harder because it is not just simply copying the first the whole given and getting the derivative. There is something uh, added. So let's do it. Find the derivative of this. So still we will copy the given, and then we're gonna multiply it with ln 3, or the natural logarithm of 3. So where do we get 3? From the base. So if it's 5 to the power of 2x, then it's gonna be ln 5. If it's 8 to the power of 2x, so it's gonna be ln 8, and so on. And then times the derivative of the exponent, which is 2. Then we're gonna arrange it. So it will be 2 times 3 to the power of 2x ln 3. So another example. Find the derivative of ln of 4x cubed, or the natural logarithm of 4x cubed. And so, um, how can we find the derivative of this? This is a bit different from the rest of our examples. So this is how you do it. First is to get the derivative of 4x cubed, which is 12x squared. We're going to multiply 3 times 4 is 12, and then subtract the exponent by 1, so it's 2. That's why it's 12x squared. Over, copy the 4x cubed, and that's it. So get the derivative of 4x cubed divided by the 4x cubed. But then this can be simplified. 12 and 4 can be divided by 4. So this becomes 3, and this becomes 1. As well as the x squared and x cubed, both can be divided by x squared. X squared divided by x squared is 1. X cubed divided by x squared is x. Then simplify. 3 times 1 is 3. Then 1 times x is x. And that's the derivative of ln 4x cubed. Another one. Find the derivative of sine of 2x to the power 5. So this is now a derivative, finding the derivative of a trigonometric function. So what is the derivative of sine? It is actually cosine. So cosine of the angle 2x to the fifth. But then aside for that, we're going to multiply it with the derivative of the angle, which is derivative of 2x to the fifth is 10x to the fourth. This is what you call the chain rule, getting the derivative of the whole times the derivative of the angle. So let's simplify further. So we're gonna arrange 10x to the fourth cosine 2x to the fifth. Another one, find the derivative of cosine of 3x to the fourth. So what is the derivative of cosine? It is negative sine. So negative sine of the angle 3x to the fourth times the derivative of the angle, which is 12x cubed. Then we're gonna arrange it, so it's gonna be negative 12x cubed sine 3x to the fourth. Another one, find the derivative of tangent 2x. So what is the derivative of tangent? It is actually secant squared. So secant squared 2x times the derivative of the angle, which is 2. And then arrange. So 2 times secant squared 2x. Another example, find the derivative of cotangent x to the fifth. So what is the derivative of cotangent? It is negative cosecant squared. And then times the derivative of the angle, which is 5x to the fourth. So arrange it, it will be negative 5x to the fourth times cosecant squared x to the fifth. So next, we're going to find the derivative of secant 2x squared. So what is the derivative of secant? It is secant tangent. So secant 2x squared times tangent 2x squared. Of course, we're going to multiply this by the angle, which is 4x. So of course, although there are two angles, 2x squared and another 2x squared, but of course you'll just multiply it by one derivative of the angle, because anyway they're just the same angle, 2x squared. And then let's arrange this. So this is equal to 4x times secant 2x squared times tangent 2x squared. So let's have our last example. Find the derivative of cosecant x cubed. So that's the derivative of cosecant. It is negative cosecant cotangent. So it is negative cosecant x cubed times cotangent x cubed. And of course, we're gonna times it with the derivative of x cubed, or the angle. So it is 3x squared. So the final answer will be negative 3x squared cosecant x cubed cotangent x cubed. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button, and also write the math topics you want to learn in the comment section.